Good morning, students. Welcome back. Chapter number 3, video number 17. In this video, we will discuss about few small topics. One of the topic is temperature dependence of resistivity or resistance. Right? It is there on page number 103 of our textbook. Temperature dependence of resistivity. There are direct equation. Okay, that is resistivity. We know its symbol is rho. T, temperature, is equal to rho 0 in bracket 1 plus alpha T minus T0. Okay, we will do the analysis afterwards. If there is a temperature dependence of resistivity, you have to use this equation. But for numericals, instead of resistivity, there is a term resistance. Okay, then same to same equation, that is RT is equal to R0 1 plus alpha T minus T0. Okay, now let us do its analysis. What is TO or T0? T0 is known as reference temperature, and at this reference temperature, what is the resistance? That is RO. So RO is known as reference resistance. Got it? So when there is a subscript O, it indicates reference. If it is TO, then it is a reference temperature, and if it is RO, then it is a reference resistance. Okay, what is T? T is nothing but given temperature. Okay, and that given temperature, what is the resistance? It is known as given resistance. Okay, the value of this resistance and temperature is given in our textbook, in our questions. And what is the reference temperature? That is TO, and at the time, what is the reference resistance? That is RO. Okay, there is one more term. Which term? Alpha. What is this alpha? Where alpha is known as temperature coefficient of either any of two, that is resistivity or resistance. Okay, so what is alpha? Alpha is known as temperature coefficient of resistivity or resistance. See, this term is most important for MCQ question, right? Or logical question, right? So many times it is asked, what is its unit? So the unit of alpha is degree Celsius inverse, or if the temperature is given in Kelvin, then it having unit Kelvin inverse. Okay, so these equations are given directly in our textbook on page number 103. Then you have to keep in mind you have to remember these two equations. Okay, on the basis of this equation there are few numericals. Okay, two numericals are there in exercise also, and two numericals are there in illustrations also. Okay, let us see. For our conveniency, we will do illustration number 3.4, or in your language, let us take it is example number 3.4. Okay, see, I am reading the question. You have to keep in mind. First of all, let us take your textbook and open that page number 105. So whatever I am writing, the analysis of the question, so you will come to know what is R0, what is T0, what is RT, and what is T. Okay? So let us take, I am reading the question. See in your textbook on page number 105. Ready? Let us see. The resistance of platinum wire of a platinum resistance thermometer at the ice point. See, what is given? Ice point. Means water start to become ice. Means it is the reference temperature and it is taken as 0 degree Celsius. And at that time, whatever the resistance is given, that is reference temperature TO, ice point 0 degree, and at that time resistance is given RO, it is how much? 5 ohm. Have you checked in your textbook? Okay. Now further. And there is a steam point. Steam point. So at that time one more temperature is given, that is T is equal to steam. Water start to become steam, it is 100 degrees Celsius, and at that time the resistance is given R100 is how much? 5.23 ohm. Got it? So there are two temperatures, that is ice point and steam point at that time. Okay, resistance at ice point and resistance at a steam point. Okay, so we know that our equation, which equation? That is RT is equal to R0 in bracket 1 plus alpha T minus T0. So first of all, what to do? Here T0 is given as 0 in our question, that is 0 degrees Celsius. So this term will become 0. So our equation becomes R0. Do it multiplication. So you will get R0 multiplied by 1 plus R0 alpha multiplied by T. Take R0 on that side. So you will get RT minus R0 is equal to R0 alpha multiplied by T. Got it? Make a subject T. So you will get T is equal to RT minus R0 upon R0 alpha, or give it equation number 1. Okay. So this is the first case for ice point. Now for a steam point, same equation you can write like this. That is RT. Instead of T, you have to take 100 minus reference resistance as it is equal to, instead of R O as it is, alpha, and there is T. So instead of T, you have to take the temperature of steam point, that is 100. Give it equation number 2. Okay, check it out. This equation number 1 and 2. Now you have to take the ratio. Which ratio? Equation number 1 ratio 2. So we are getting RT minus R0 upon R100 minus R0 is equal to R0 alpha multiplied by T upon R0 alpha multiplied by 100. So this two term will cancel out. What to find? Still, the question is remaining. Okay, so first of all, let us see once again. So first equation we took for ice point. Similarly, we took another equation for steam point. Okay, mind well students, this is 3 mark question. So for ice point, you have to show the complete calculation, and similarly you have to write for a steam point. Then you have to take a ratio 1 ratio 2. Is it okay? Then what is the question? Just it is remaining. What to do? See, when the thermometer is inserted into a hot bath, oh my god, one more point is given. It is nothing but hot bath. Got it? A hot bath. The resistance of a platinum wire is 5.795 ohm. So one more resistance is given, 5.795 ohm. Okay, then calculate the temperature O. So you have to find the temperature T, and for that resistance is given, it is RT. So RT is already here. Now place the values. Let us see. Make a subject T, 100 will go here. So you will get, we are writing that equation once again. See, it is already there in our textbook. That is RT minus R0 upon R100 minus R0 multiplied by 100 is equal to T. Now just place the values. What is given? RT, that is 5.795 minus R0 reference resistance 5, R100 it is 5.23 minus again reference resistance 5 multiplied by 100. Do the calculation. You will get 5.795 minus 5. It is 0.795 divided by 0.23 multiplied by 100. So finally it is a simple calculation. You will get temperature T is equal to 345 0.60 or roundabout it is given 65.65. It is degree Celsius. Alright, so by this way you can use the equation which is given directly. Have a look in your textbook. Most of the equations are given directly, but we have solved it. Okay? Similar question is there. You have to solve by using this equation only. Now let us take exercise example number 3.5. Okay, now let us see exercise example number 3.5. Again, take textbook, read the question carefully, and then we will do analysis. Okay, ready? So let us see. It is exercise example 3.5. What is given? Let us see. At room temperature is given 27 degree Celsius. At a room temperature, the resistance of a heating element is 100 ohm. Means one resistance is given, that is R. It is given how much? 100 ohm. But when? That is 27. It is given room temperature. Further, what is the temperature of an element? So again you have to find T. What is the temperature of an element? So T you have to find. If the resistance is found to be 117, means you have to find T when resistance at this temperature, means at a temperature T is 117 ohm. Okay, so this temperature you have to find. It is a reference temperature, so you have to take, that is TO is equal to 27 degree Celsius. Why? Because temperature is given, room temperature 27, and at that time whatever the resistance is there, it is also given, but you have to find the temperature at which the resistance is RT. One more thing, it is given, what is given? Alpha. What is alpha? Temperature coefficient, and its value is alpha is equal to 1.7 multiplied by 10 raised to 1.7 multiplied by 10 raised to how much? -4 degree Celsius inverse. Okay, then simple. You have to take the help of our our equation. Which equation? That is RT is equal to R0 in bracket 1 plus alpha T minus T0. So here you have to take what? RT. RT is here, that is 117 is equal to R0. R0 means reference resistance, that is reference resistance at room temperature, it is how much? 100. In bracket 1 plus value of alpha is given, that we will put later on. T you have to find minus TO. TO means reference temperature. It is 27 degree Celsius. Okay. From that, make a subject alpha. Before that, you have to multiply that 100 inside. So it is 100 plus 100 multiplied by alpha multiplied by T minus 27. Take 100 on this side. So you will get 117 minus 100 is equal to rest of the term. That is 100 multiplied by alpha multiplied by T minus 27. Okay, what to find? You have to find this T minus 27. So make it subject. So it is T minus 27 is equal to 117 minus 100. That is 17 divided by 100 as it is multiplied by value of alpha. What is alpha? That is 1.7 multiplied by 10 raised to minus 4. So calculation is very easy. That is 17 divided by 1.7 multiplied by 10 raised to, it is minus 4. Here 100 means 10 raised to 2. So it will be minus 2. Take it upside. So you will get 17 multiplied by 10 raised to 2 divided by 1.7. Then T is equal to, when you will do its calculation, it will be how much? You have a calci, then it will be 1000. Take 27 on this side. So it is plus 27. So you will get temperature is equal to 1027 degree Celsius. Okay. By this way, you have to solve the numericals by using equation. Got it? So there are few more numericals in our textbook that I will give you in your homework, and for that you have to check the assignment, as well as you must have to do homework regularly. Why? Because all these things are for you and you only. Okay? Thank you.